First of all, we wanted to thank you all for coming, and it's very, very nice to see you here in person, and that is finally possible to meet like that. Today, we would like to introduce you to our world, to tell you something more about both Scrum and robotics, and a little bit about our company as well. And we would like to keep this presentation more in a form of a discussion. So if you have any questions, feel free to interrupt anytime. Actually, we don't mind being asked questions. Maybe it can happen that we won't be able to answer to all of them because of our business. We are still very, very early startup, but still we will try to, as much as possible, to share details about what we do. So for the beginning, we wanted to share a movie with you so you could see what we are going to talk about next.
So this is actually our lab. These are those trends that I mentioned at the beginning. So when you come to the office, you can say, "Hello, my dear robots."
Yeah, there's no sound, but it's not very
And this
important
is from
here.
From the real warehouse. So as you can see here, the robot is actually taking different items, moving them, sometimes scanning those moves around. It's not an accident. The robot tries to identify the object thanks to scanner. It's mounted in a robotic station.
In which phase you identify the object before picking up, during?
Indifferent, I would say. I will try to give you more insight how this is happening during later part of presentation.
Okay. So now maybe a little bit of introduction. So something about us. So you can basically read a very short poem written by my friend next to me. So I'm responsible for recruitment at Nomagic. I'm mostly dealing since actually a couple of years with technical profiles. So actually it's a good fit to Nomagic because majority of our team are engineers. So this is the main area that we're operating in. And what else? So my main goal is to find the right fit for Nomagic. We have a great team, so we put a lot of attention to how we are hiring. And from a personal side, as you can see, I'm a dog person, totally 100%. So in my free time, I'm mostly going for walks with this guy here on the picture. And Asha, your introduction now.
Okay, so I love the robots, and I hope that you already know that. If not, I will emphasize it one more time. So I'm a Scrum Master. Fun fact is that my educational background is related to control engineering and robotics. So I think that this is one of the reasons why I work at Nomagic, because I have robots and I'm a Scrum Master. Great deal. And when it comes to my hobbies, well, I'm a crocheter. And this is my recent project. I'm trying to do more 3D structures. So let's see if I can be better and better in that area.
And if you were wondering why we are here together today, Asha was actually the first person I was hiring for Nomagic. So it was about a year ago when I joined. Asha was the first person even which I called. So that was a big coincidence. And of course it resulted with the fact that we are working together. And despite my role is in recruitment, Asia's role is in something totally different, in project management, let's say, if we can put it this way. Our paths are really crossing very often because we are a startup, a very early, maybe not very, but early stage startup. So it's not that our roles are very limited to some areas. And it's great that we actually have this possibility to work together. So this is why we are here today. And maybe this is not the first time when you see this logo and the name Nomagic, but we wanted to tell something more about our name. So how it actually happened that we are called this way, not the other one, because we are a robotics company, and it only states that it's Nomagic. So basically, there is no coincidence in this particular name. We even double-checked with Kacper, our CEO, last week. Is it so we were assuming why is it Nomagic, but we weren't really sure. But it turned out that that what we thought is true. So there is something like Clarke's laws. So the first Clarke's law says that when an older scientist, like this man on the picture, says that something is possible, it's probably true. But when the same person is saying that something is impossible, then this person probably is wrong. So this is the first Clarke's law. The second one says that the only way of actually checking if what are the limits of possible is to pass a little way behind this possible that you can see here on this picture into the impossible.
And basically, I really like this picture because, spoiler alert, as you can see here, it comes from Illustrated Guide to PhD. And this is a symbol that when you are doing a scientific research, for example, as a PhD student, you try to make the whole knowledge of the world bigger. And when you see this big picture, it might be from a perspective of a random person, like simply nothing. But if you succeed to do it, yay, your PhD was successful. And there's a lot of science in Scrum. Again, spoiler alert, we will be talking about it more today.
And there's a third Clarke's law, and it's especially important in our case, so that's why we even wrote it down here. And it says that any sufficiently advanced technology is indistinguishable from magic. What is a direct connotation to our name, and there is also a story behind that. So it's not like Kacper just came out with those three laws and he said that okay, we will call ourselves Nomagic. But there was a story. Maybe Asia will help me with this as well. But Kacper was somewhere in Germany, right, in Berlin. And he was hanging out in some bar with other engineers, as far as I remember. And in Berlin, it's very often that they are not accepting credit payments. They prefer to just receive cash. So Kacper came there, wanted to pay for what they ordered, and wanted to pay with the card. So the lady who was accepting this payment said, okay. So she wanted to insert Kacper's card into this terminal, and Kacper, instead of doing that, just put this card and did this wireless payment.
Contactless payment.
Contactless payment. Yeah. So this lady was like, "Oh my God, it's magic!" Something like that. She was very, very surprised because she didn't know it before, and this is how he actually thought that what we are trying to do at our company, which didn't have name back then, it's really it's not a magic. It's just technology. So this is how it happened. I hope I said it correctly.
Yeah, exactly. So that they knew Clarke's law, But actually, the lady in the Berlin started yet another discussion about it, and Kasper said like, "Oh my God, I thought like Nomagic. This is the name that I want to use in the future."
Since we know that there is no magic in what we're actually doing, then what is like the main characteristic of us? So we thought with Asia about the three main things when we were preparing this presentation. So first one, obviously robots, because this is something that makes us different from many other companies. Basically everything is around robots at Nomagic. They have their own names, so we could just make some differences between them. Everyone closer or not very directly, but is working on some robotics topics. So it's not like we see those machines, I don't know, once per week or something like that. It's really our daily routine to work with them or to just be in the same place. So this is the first thing.
Yeah, and this is our staging environment.
Yeah, and our engineers as well. Second thing is that we work with something physical. So our engineers, whenever they are writing some new pieces of code, they can just come and test it very, like, I don't know, 5 minutes after they are writing something. So this is what they think is also kind of interesting and something different also from many other environments that they worked in before. And here we can see you were feeding a robot, right?
Yes,
on
I'm
this picture.
feeding with my love, exactly.
Yeah, so,
okay,
so
maybe
this,
I can add more comments. So this is the gripper. So this is we call it anti-factor, the thing that is used to actually do something with the robot, because when you buy the robot, it's nice, but it basically does nothing. It moves. It can be moved, but you have to install something on it. And this gripper is ended with a suction cup. So basically what I was trying to do is like put my hand near to it to check if the pressure is good. And we have different suction cups, but basically this is the same thing, but with a bigger suction cup, a bit different type, but this is what kind of grippers and suction cups we use.
Yeah, so basically we are working with different kinds of robots than on the poster, but yeah. And last but not least, of course, we have great people who are often put in interesting circumstances, I would say, as here on this picture on the bottom right. We have people with, I would say, different backgrounds, and we definitely not only hiring senior people. Each year we try to also create some internships and stuff like that. So yeah, so we have very diverse backgrounds and histories behind them. You can also see our founders in this picture in the middle. Marek, so from the left, Kacper, Marek, and Tristan. Some other pictures from the office as well, and one more from some kind of an event during summer. And now we will be switching more, I would say, into technical details of what we're working on, and also to some hardware related topics. So I think Asia will be taking over.
Exactly. So now the fun is already said by Justyna, and now will be boring things. If I will be boring, please give me feedback. But I will try to be at least a bit entertaining. So you've seen the movie. Maybe you already have some kind of understanding what we are doing. Could you please share your thoughts? What we are solving with our solution? Very good. Now let's try to be more specific. What are those robots doing? Why they are difficult?
Repetitive repetitive tasks.
Yes, very good one. Repetitive tasks in logistics, in warehouse. Replacing people. In tedious tasks when they have to do like beep, beep. Believe me or not, it's a very, very boring work for people. Great. Any other thoughts? Scanning products, very good. Not in every use case, but yes. Okay, so why we are solving that problem, and let's try to be more specific about that problem. So currently in big warehouses, what could be easily automated is already automated. What does it mean? We have automatic conveyors, we have different systems that are used to take things from one part of the warehouse and put it to another to make this logistic process effective. The problem is in a few, maybe several parts of that system where humans are standing for few hours or maybe even more a day and doing what I try to present just before the moment. So there are different approaches. Sometimes it's like in fashion, picking something in foil, which is soft, so it behaves a bit different than a box, scanning it and putting it to the chute, and this automatic chute now is taking it to another place of the warehouse. Sometimes it's in e-commerce, actually this is Tetris here. So it's not only about picking, it's also about planning how to put those bricks together to be effective. Sometimes precision and high quality is crucial, because if the robot destroys some things, the cost of such errors is high. So many people, when think about robots, can remind some movies from YouTube. Have you seen those dancing robots or doing some crazy stuff? Yay! We know that. Why our robots are not dancing and doing such boring things? I will tell you our little dirty secrets from robotic world. It's relatively easy to program the robot to do those fancy moves. I mean that if the environment is stable and we want to have some crazy ideas with this robot, I don't know, jumping, whatever. Usually it's quite easily possible. You take average robotic engineer and he or she does that. The problem is that in our environment we have warehouses with thousands and thousands of different items. They are changing because of season in clothes. Different things are sold during winter, different during summer. They have different sizes, different weight. And what is more, depending on the use case, depending on what warehouse, what kind of data then they can provide us, we may know something about those boxes arriving to robotic station, but we may also know very little. And those items might not be so well organized like over here. It might look like that. And now, let's look. I hope you see it. Random pile of the things. And this is typical for us. Now, what the human does? Okay, I have my own eyes. I'm taking those things. I know how to organize it. I know how to do it one by one. So, at the very beginning, it might be fun. It might be interesting to learn how to optimize those moves, how to optimize my working place. But in general, for humans, it is boring. It is boring. It's not good for your neck, for your back, if you do it in positions that are not pleasant for you. So we cannot pre-program our robots. They need artificial intelligence. They need signals from cameras, from different sensors, to be able, trying to answer your question, on different moments in this whole cycle, which starts before picking and ends when the picking was successful and the robot finished what it is supposed to do. We have a lot of data from different sensors. And we have live neural networks, we have our machine learning algorithm that helps us predict what to do. But this is not the world where we do fancy moves. It's much complex world. So, complexity. Who knows Scrum and Agile likes the complex world? Pavel, you seem not convinced. It's okay, but his face was like, don't you like a complex world, and don't you like the picture? It's not nice. I'm sorry. Okay, so as you can imagine, our complexity has different sources. So on one hand, I told you about this random pail. This is just one example. If you know anything about machine learning, artificial intelligence, you know that we do in such a way that we show some data to such a system, to such neural network. We train it to recognize different patterns, to learn how to behave, and then we can use it. But the big constraint is that if you train it in a certain conditions, when conditions change, well, it might be working or might not. For us, lightning. This is one of the very important aspects. So if somebody in the warehouse decides to change lightning and does not inform us, it might affect effectiveness of our system. So how we work in Nomagic, what are the things that we often hear? Did you test it on the robot? I would say my favorite one. Do you have enough tests? Do you have data? Do you have evidence that what you predict will happen? Because you know it's unpredictable what will be there. I'm curious. What happened if we change that gripper into something different? Or maybe let's completely find some new crazy idea. So 4 words that I would use to describe roughly our attitude and our mindset. On one hand, it's curiosity. It's curiosity, what will happen, what will be the impact, what will be the change in our system if we do something. Combined together with doubts, I think that when you start becoming 100% sure that you know everything, well, you might not feel comfortable with us. I think that those doubts is something that is incorporated. It's a part of the way how we are organized, how we think. And those things are supported by data. So we use a lot of data. I even have my favorite T-shirt for such presentations. So face the brutal facts. This is something that we say quite often. Let's face them. And exploration, natural thing that happens. We are constantly looking for solutions, for different ideas, for inspiration. We are checking on the market what's available. Maybe someone is selling a new gripper that can be used in our system. So our station, I'm not sure if it's clear for you now. It's a robot with a gripper and with the whole mechanical and hardware parts. Some of them can be bought, but some of them are designed and manufactured by our engineers. And this together, mounted in a setup, in production setup, like in the warehouse, this is our robotic station. This is actually the whole product. Okay, so many of you mentioned in the survey during signing to this meetup that you're interested in hardware. So thank you very much for that feedback. I will try to gather now some of the challenges and try to reference how do I, as Scrum Master, see them in terms of Scrum. And another spoiler alert, Scrum is not fully good, fully convenient for us because of some of those mentioned challenges. Let's look at them. But before I go there, can you name or can you guess some of the things that are difficult for us?
Hardware design, timelines.
Very good. Eva?
Very expensive resources.
Yes. Yes. Buying a robot is not like that.
Getting parts from the third parties.
Exactly. External dependencies. Plus, if you have ever been in ordering things, you know what's happening there. It's a process, and you have to coordinate some of the things. If only one part is missing, but this is a crucial part, you cannot mount the tool as a whole. Great, great.
The issue with sensor, for example, you check that you can use some sensor, and after testing it's not working one sensor with another element,
Uh-huh.
and you must redesign the PCB and make again iteration.
If you don't mind, I will try to paraphrase it. Integrating different things together. This is a big challenge. I agree. I fully agree. Hmm?
Another thing would be very, very high cost of redesign. Like if you change one small thing because it doesn't work, you sometimes need to redesign the whole thing from scratch.
However, I think we even had the discussion today in the morning. We have some ideas that actually we are doing several types of prototyping, and some of them are not so costly. So I will share that. Okay, so let's look at that. I hope that you are not bored. Because when I look at Pavel, I'm a bit upset that maybe I should stop talking. Okay, you mentioned that hardware is designed and manufactured. So basically, I will try to compare it to the software world. Continuous deployment is not possible. Due to obvious reason, you mentioned at least great examples. And also the cost is a bit different. Of course, you can try to, for example, design it in a way that it will be easier to plug and play, but it's always a discussion of what is the most important for you. And based on our experience so far, but based on what I observed, if your goal will be to have it easy to plug and play, maybe it not be optimal from your business case point of view. So we are more client-centric. This is, I think, something consistent with Scrum and Agile. We tend to rather think about delivering the best possible value for the client, so it's not so easy to plug and play with everything. Sometimes it's possible, but this is not our basic goal. Copy-paste does not work, another thing. And unfortunately, copying fully working robotic station has its own challenges. Because let's imagine such a situation that our client wants to have more automized stations. Great, we are doing a few in parallel stations, but they're almost the same. But the cable on one of them is mounted in a different way. So maybe in short term, it will be not noticeable by our system or for us. But if this way, in some of the cases where robot has to do some very specific moves, if it will be getting too tight, we can even destroy this cable. So the doing copy-paste in that world, it's not only it does not exist, it has its own challenges. Cloud solutions. So actually storing the parts, storing your robot. You have seen it on the movies. Our robots have need significant space in our laboratory. So this is another thing that you have to do, take into account. So your staging environment is quite big, I think much bigger than this table, so that you can mount safely robot and mimic somehow production environment with those boxes, with cameras, scanners, and so on. Safety first. Maybe I should actually start with that. So in general, I would say that software is a bit safer. And when it comes to hardware, safety is a really important thing. And in robotics, in our case, I would say it's very, very important. So a friend of mine is working as a control engineer, and she told me once a story that such a thing does not happen often. But if somehow robot takes an item and decides, somehow it's an error, it happens. We have software, we have hardware integration issues, decides to throw it. Such robot moves with a speed of a few meters per second. So it's like it can kill you. It can even kill you because of this force. It's not an accident that such robots are in metal cages. They are not wild animals, but they are dangerous. In that sense, safety is so important that you cannot choose to do a part of it. It has to be always top priority for you. This is the problem, one of the problems that I think is beating us in our face. Reality gap. In warehouses, we have thousands of items. They are changing. They are buying new stuff because their clients want to buy new stuff. We are not able to have all those items in our lab, first thing. And the second, the whole sophisticated system with conveyors, with some integrators. It's a big thing, it's a costly thing, we do not do it. So our tests, if we try to reference, for example, to the concept of DoD, unfortunately, our last and final tests that we can treat like something relevant is on production. Because testing, in our case, is always only to some extent. It does not mean that we do not try to mimic it. Of course, we create some items that try to represent our challenging items on production. We are looking what's happening. In general, when it comes to software that controls robot moves, we can test several commits a day on the robot. That's great. But the problem is this is not something so strong, and I have a problem with DoD in our case. This is our reality gap. So maybe not so fully Scrumish, unfortunately. You mentioned dependencies on external factors, very good examples that we rely on somebody else. Another very difficult thing, if a company X decides to stop supporting certain library, well, we can create a copy, we can maintain it for our own purpose, we can somehow survive. Let's imagine a disaster, like a big fire in the factory that produces cameras that we use. Well, we cannot copy that factory. For us, changing the whole set of cameras, it's a big problem. I would say we have some additional risks that we have to take into account. In general, I think that we are talking a lot about I-shaped people, T-shaped, pie-shaped, cam-shaped, and so on. In hardware world, I wouldn't say it's impossible, but it's quite challenging. Why? One, safety first. Some of the things that we are doing requires preparations, to special trainings, and the law requires that somebody has a relevant certification process passed. What is more, for example, if we look at designing parts, so you need a very special and deep knowledge about physics, about maths, about materials, mechanics, and so on. Then the software that is used for those simulations, it's always quite complicated, I would say. So if somebody is a very good designer, there's a risk that it's not so easy for them to extend this, to be very good in more than one domain. So T-shaped, yes, to some extent, but it's, for me, from my perspective, it's more difficult to go into pie-shaped or the other. Okay, and last 3 challenges. I think that I already tried to mention a bit. When it comes to our pie, in software, we think that we try to have like nice cut with all the layers so that we can taste everything. In hardware, sorry, safety first. So you have your first layer as a whole. Then some first basics. Okay, without a robot, without at least some of the parts of the hardware, you cannot start it. So basically, maybe you do not have the next layer as a whole, but 60%, 70%. Our cake in this world is not so nice. Another challenge, because we think that our system consists of 3 parts that coexist together, influence each other, but they are different when it comes to looking for a solution. So when we say software, we think about all that code that helps us move the robot, plan those moves, decide about those moves based on data from machine learning system. So this is this AI that provides predictions, provides data based on environment, what they were able to recognize. And of course, we have hardware. So in our world, it's really, really difficult to assess when looking at particular problem, what to do. So this is another challenge. On one hand, it sounds like, hey, you have so different areas to explore. But as I think some of you already mentioned, if we made wrong mistakes, especially when it comes to hardware, it's a bigger cost of money, but sometimes we can handle that money if it's not so big. The bigger problem is our time. We are early stage startup. We do not like clock saying. If it does not work on the real robot, it does not work at all. So this is something that I would say is very client-centric, and this is something that we try to remind ourselves a lot. So no matter how great ideas we have, our clients want to see solution working in warehouse, which means it has to work on the real robot. Any questions so far?
What is ML? Is it software, hardware, and what's ML?
It's machine learning, so basically it is software, but it is related to neural networks, to models that helps us train the robot to recognize objects, recognize their dimensions. Yes?
You mentioned several times safety first approach. How do you deal with human error?
In what situations?
In general, so when you have a safety issue or hypothetical, and this is generated by a human error, how do you deal with in this context?
I'm not sure how should I answer that question, because I do not feel I understand. I cannot reference it to a real life example.
Your robot throws something and potentially kills someone.
Okay,
and
so
this is generated by a human error.
Okay,
So
okay.
someone made a mistake.
Okay, so basically what safety first means, you try to predict all the situations when the robot can kill somebody. So when my friend was telling me that story, it did not made any harm to a person. I think that the item was destroyed and robot was a bit destroyed. But in general, the robot is closed in a cage. And if that cage is somebody tries to open, the system automatically emergency stop. So the robot stops no matter what, and it's quite safe to come inside. What is more, it's industrial standard that you have safety, big red safety buttons. So whenever you notice something is wrong, due to any reasons, boom. So actually you design it in such a way like the robot is a wild animal that can go outside and kill you. So you close it in the cage, you have safety buttons, maybe there are some other solutions despite those 2 things, but they are always done in such a way. I haven't heard from my colleagues that robot killed someone in last years. at least from my studies. So there were some problems, for sure. But we planned the system in such a way that worst case scenario is that item is destroyed or item and robot are destroyed. Okay, any more questions?
What is like your daily job? Like, what do? Do you code? Are you a project manager?
I'm Scrum Master.
Okay, sorry. I was wondering.
Okay, I'm Scrum Master, but that's a good question. What do you do? I do different things. And
Like when you put up a show, you can see all this amazing stuff going on. So that's what I'm wondering.
yeah, I'm involved as a Scrum Master. So basically, I'm not coding, but I participate in discussion. I'm a facilitator. Sometimes I'm also generating ideas like, hey, I think that I have an idea, let's do it. And basically, I think it's a very good question to start our history of prototyping, and actually it's mine and Justina's today discussion. We have several types of prototyping, and for me it's so agile-ish and scrumish. It's wonderful. I see Scrum in such a way that it helps us mitigate risks, which means that if I have stupid idea, I want to learn quickly. That is a stupid idea. So the quicker we prototype, the better. What we do, and these are guys from our hardware engineers, our hardware support, and I love spending times with them because they have a lot of things. They are doing a lot of manual things. So for me, it's so relaxing. Sometimes they even allow me to do some simple things together with him. Wonderful. So first step of prototyping is going to the whiteboard. These are people who have such great knowledge and great imagination that they are drawing and they can visualize in their mind how it will be moving. And I'm just standing and like, okay, this I get it, that, no guys, sorry. And say, okay, Joanna, don't worry. Next step, I would call it MacGyver's tape. Tape, duct tape, glue, paper, carton box, whatever you can to mimic some of your solution. For example, is it worth to put something, whatever it means, for example, some sensor or camera on the robot? If we want to quickly learn if it will cause some problems with hitting the cage or hitting the things around like cameras or whatever, why not to create a box with the shape of this camera, use a tape, put it on the robot, and start running our code, our last stable code. Why? Because imagine if there will be some problems in their moves that happen a lot, we will see it in a short iteration. We will see it when doing several evaluations that, hey, robot is hitting that carton box. If we destroy it, who cares? This is just a tape and a carton box. But we've learned that, okay, it may require some changes also in software. Do we want to invest it? Or maybe it's not the right time to do it. Another step. Justina today asked, so I thought that 3D printing is something common. Of course it is, but it takes time. For example, you program your 3D printer and wait for the whole night. Come on, if we can do something quicker, let's go to the lab, let's do it quickly. I remember such days when we are trying to understand what are the possibilities to extend our solution, and we are iterating daily with hardware. It was so cool. They were doing ugly things, but they worked long enough. And they were able to prove that some of the ideas might be good, some of them not. From that step, we are going to the more mature solutions, like creating a design of a real prototype, and then we have to create visualizations, we have to look at it from different angles, we have to send it to manufacturing companies, wait for it, and then mount. And basically, usually it's not the end, because this prototype may be working for days, maybe for weeks, maybe for months. It might be not the last one in our process. So before we have something more stable, final, costly, we can do different steps. And it's so fun to be MacGyver from time to time. Okay, so I hope it gave you some understanding about hardware, about what kind of challenges we have. I don't know your context. Maybe it will be different for different company. For Nomagic, this is I think quite good introduction. And now, I have observed in the past such an idea that this is how we develop products. So basically, there's an idea. It may come from different sources. It might be from project lead, project manager, product owner, from the customer. Then this idea is implemented and deployed. And of course, at the end, there is a customer who is happy. And we have a fantastic machine that produces awesome features. But I trust that you know that this approach is simplified and it does not work in a complex world, because you do not know if you satisfied customer needs, you predict impact of your changes. If it will be so easy, maybe more money will be easily earned by many companies, but it's not. So what we as Nomagic try to teach others, to inspire others, to think about this model and missing parts, and do it in more, spoiler alert, scientific way. Because we do not trust in fluffy Scrum, but we trust in very scientific Scrum. So if science, then we need clear goals, evidence, and data gathered correctly. So before we actually start the work, let's look for the answers for those questions. So to have a common understanding, what is the problem? If we ask our engineers to create, I don't know, new theme in our app, banking account app, to change the color, they will do it. But in general, and I think it's proven by experience of many people, it's better to tell people what is the goal behind those changes, what we want to achieve, and why we are actually doing that. Because they can challenge our ideas, and that's fine. Then, if we agree that we have a common understanding, what is the problem? We all agree, yes, this is an elephant. This is an elephant, and we do not like elephants. What do we do with this? How we will know that the problem is resolved or our goal is achieved? How will you recognize that that this elephant just went away and you cannot see? Well, no elephant in the room, more fresh air. Which data will you need? And how often will you collect data? Why I'm emphasizing how and how often? There is a chance that in some of the system, gathering data is just like that. It will not affect performance a lot or at all. It's just a matter of implementing this whole gathering and handling it properly. But sometimes gathering data is a cost. So it has to be, in my opinion, conscious decision. I promise that we will be talking about science, and this is my hypothesis, that maybe it's a good moment to think about our work as a science. So have you ever thought about yourself as a scientist? Yes, awesome. And we earlier we showed you the photo with this PhD. Again, it's not an accident, no magic, no coincidence. I trust and I believe that PhD and the science approach has a lot in common with Scrum. So if you look at the definition of science that my professor from, by the way, Wrocław University of Science and Technology was repeating a lot. there's an important word here, which we want to emphasize today. We are talking about hypothesis. So, no certain things, a lot of doubts, and we are trying to guess, describe our world, describe some kind of relation or effect of something, and this is the hypothesis. So, the most important thing for now, there's always a doubt when it comes to hypothesis, even if you prove it. You prove it by conducting experiments, another scientific word, but I trust it's very useful for us, but it's never 100%. So it's a part of this approach. On one hand, curiosity, but doubts. This is something that will always be with you, because in hypothesis theory, we have different kind of errors. And for example, you can have false positive, false negative. What different things can happen, and this is this taking from this thinking like this is the truth, this is my reality, this is my hypothesis. So going back to this, it hasn't been disproven so far. And the friend of mine, Julia, who's a specialist in data analysis area, she claims that if you prove the hypothesis that it's right, great, this is just the first step of a journey. Because maybe will be this case, particular case, that you will land into the error that is always incorporated in that. Okay, so another science, another good points. So hypothesis can be tested, and also if it is false, you can conduct experiment that will help you understand that it's false. And this is something that scientists claim this is important. If you create a hypothesis that majority of cats in Poland are black, you need to be able to prove, to disprove this hypothesis. Well, you can. It's an experiment that you can conduct. You go to the cat shelter and you gather data. You have your sample. The hypothesis has to be logical and positive. Positive in that sense that we do not create hypothesis as a negation of something. It should be a positive statement describing some of the effect, some of the relationship between different variables. Oh my God, I think that it's getting boring. I'm sorry. Or maybe this is just because late. But I have a proof that I did not came here with some boring stuff who should be completely new for you. Lean UX. So they are already mentioning hypothesis in Lean UX canvas. There's also the idea of hypothesis prioritization. I'm not saying something new. This is something already visible in Agile world, worth digging more. But I encourage you to go a bit more and think broader, not only in terms of UX. So, you remember that? Let's add more data. So this is the first step. Data when it comes to creating ideas for feature, data before you starting implementing, data during implementation. So let's encourage ourselves, like if during creating some new features we realize that it's not the best idea, let's abandon that. Let's limit this effort and do not be like narrow-minded, like we have to do it. Let's stop whenever you realize that this solution, this new gripper is not a good solution. That's a pity. It's good that we learn today, not in 6 months, for example. Sometimes our environment may change. Even before deploying, you may need to make a tough decision whether I should deploy it or not. And it also happened to us. We deployed a feature and we realized, oh my God, the data before were saying do it. But here we realized, let's revert it. But be always open for abandoning feature, reverting that, be able to embrace the change. If possible, include customer, include data. Look at that. I will go here. If we are able to collect some data from warehouses, thanks to our clients, we can use them over here. We can go through implementation of our feature together with our client, having some feedback loops, having some collaboration, trying different approaches. Maybe we can do, when it comes to software, something really small and test it on production quicker. As you already know, when it comes to hardware, it requires more effort before something can be taken into production. But again, it might be still some kind of a prototype. More mature, but still prototype. And big kudos to Julia. Julia, I love our friend Julia because sometimes when she say one statement is like mind opener. Data is not an information. Why?
Process data is an information.
Process data, okay. Any other ideas? Analyze this. So maybe analyze data. Any other ideas?
It lacks context.
Mm-hmm.
How we gather this data.
Uh-huh. So seems like it's more complicated. You cannot just take data and treat it as the truth. Now, let me tell you an example. We decided to implement those changes in the app, okay? And we changed the color, we changed some settings, and we realized that before the change on our sample, we have conversion rate like 15%, and after that change, we have 16%. What does it mean? Which solution is better? Or maybe you have, okay, I will try to make it easier. We can have like 18%. Let's make the difference bigger. 15 and 18. Which is better? It depends. Universal answer of the coach. And why it depends?
That's what we're trying to do.
Uh-huh.
Depends actually, if that's the only source of the change.
Very good.
Or there are more. If you can build a model out of that, meta model of that,
Mm-hmm.
then it's probably true.
Okay, so very, very good point. One thing is that something could change. And it might be our product, it might be environment, it might be whatever. That's the one case. And the other, if it's data based on samples, average is not enough, my dears. Because maybe your samples are not of enough size. Maybe your confidence intervals, statistic math, sorry for overusing it, but maybe this is not what you are trying to reach. Maybe if you analyze data, thank you for the word analysis, if you analyze data using math, using statistical tools, which you do not have to be very good at it because there are great solutions on the market available. But if you look into the details, it may appear that, sorry, okay, you see those averages, but you cannot trust them. So not only gathering data, but also being conscious when it comes to analyzing the data. And something may change around you. It may also affect you. What is more, if you're trying to check few hypotheses in parallel, it's more and more difficult to catch impact of a certain one. Okay, so I promised new friends, I promised science. I strongly encourage you to not only be inspired by Lean UX, by thinking like hypothesis, having these additional glasses, for example, like right now, let's look and change our perspective. Let's look at this problem through hypothesis classes. But I also encourage you to go a bit deeper into math. So in that case, I would say, yes, Scrum is not fluffy. It's so scientific. It's so mathematical. In the invitation for this meetup, we also mentioned that there's a lot of evidence-based management. So this, what we have spoken so far, for me has a lot of in common with EBM. How many of you read Evidence-Based Management Guide? Oh my God, Paweł, I cannot look at you, really. Your face is like... So, if you recall, this is the picture from EBM Guide. And again, my favorite word is here. Sorry. Hypothesis. So, how do we move towards our goal? Through experiment loops. So this is so consistent with what we do in Nomagic. What I'm personally lacking in EBM Guide, too little math and too little saying it loud. It's very scientific. It's okay to go into that solutions, into that tools in our Scrum Masters, Agile Coach, or any kind of the role. In our suitcase of very fantastic tools, we have also math. We have also statistics. They are very, very nice, very specific tools, and they can help us make right decisions. Sometimes we move faster, sometimes slower, but every experiment loop is focused on proving or disproving hypotheses. Okay. What I wanted, together with Justyna, to tell you today, that it's great to feel, at least sometimes, as a scientist. Why? Because science is great, science is fun, but science is also for very serious people. And we, at Nomagic, I think that it's not an accident that there is a relevant group of people with PhD or during PhDs, but also there are some who claim that, well, I was thinking about PhD, but when I joined Nomagic and I observed a totally different approach to work, like actually we are doing a lot of this, I no longer had this need because I already feel like I'm during my PhD. So it's serious, no fluffy Scrum, and scientists are very serious people. This is Maciej, our great hardware deployment manager, very, very, very knowledgeable person, very serious man, but sometimes, of course, we are just people and we are also laughing. And our robots are doing with us all those different things to help people avoid tedious, boring, repeatable tasks, but they are not afraid of any work, and we sometimes also have fun with them. So this is our movie related with Easter. Justyna, do you recall the name of that robot?
I'm not sure.
Yeah, me neither, because we are having more and more robots. So that was just one of our robots helping us prepare for Easter. Most likely we will be also preparing for this winter for Christmas. So, once again, no, not necessarily. And, dears, that was all that we wanted to say today. If you have any questions, we are happy to answer them. Please ask.
In production, usually when there is a lot of machine, we have SCADA systems, and the problems that we need two separate networks,
Mhm.
internal and external. Is it the same with robotics, with this kind of machines?
I'm not sure if I understand.
Yeah, because we need to have internal system, internal data gathering. Because
Uh-huh.
this is a big vulnerability to cyber breach or something.
I see.
You know, mix the data
Uh-huh.
or even trigger a machine to do a harm. So I'm wondering, with the safety first, is it the same case with robotics?
I'm not sure if I'm the right person to answer that. That's a very good point in general. However, when it comes to safety, we have hardware solutions that are, as we already discussed. So when it comes to data, I think yes, this is something that we have to take into account to keep our data safe. But when it comes to hardware, I think that no matter happens, we always have some hardware solutions that stop us from silly or very dangerous errors.
How do you work with Scrum?
Our software teams are usually following Scrum in the terms that they are. We have our product goal, so we understand what we have to achieve to have a good product market fit and to feel that, hey, this is the product that is ready, is mature, we can be very proud of it. So we can cascade that product goal into smaller goals, and basically we land with some sprint goals. So our Scrum teams organize to achieve those goals, and they work in sprints. So in software, it's not challenging when it comes so much as it comes to timing, because software is continuously tested, and we aim as Scrum teams to have a done increment at least once a sprint, but we try to have it continuous in a continuous way. When it comes to the hardware, I would say it's a mixture of some Scrum inspirations and a bit of Kanban, and I think we will be going more into Kanban way, because in many of the situations it seems to be more natural. And we can also think that for our hardware teams, because some of the work is maintenance. You have to maintain robotic stations, you have to do some things that are not from, let's say, this complex domain, and some of them are R&D. It sounds like a good candidate for a very good Kanban, so we are on this path.
I have a question about the source of the product's ideas.
Uh-huh.
Like, you know, what the robot should do.
Mm-hmm.
Is it something that you guys are building internally as a product hypothesis, not a solution hypothesis?
Mm-hmm.
Or is it more like the client, there is a client, he has a concrete problem to solve, and
Uh-huh.
this is the source of.
Okay, so from business point of view, it's relatively simple, because we are trying to work very close to our clients or to potential clients. This is important part of Nomagic, that this collaboration with the client, actually like purely from Agile Manifesto, is really, really important. So thanks to communication, our visits to warehouses, we realize what is the goal from business point of view. So we already have, I would say, quite good understanding what are the conditions that our product has to give to the clients. And how to do it, I think that majority or almost all the ideas are our internal. Because I think it's one of our guys from Photos, Wojtek, said once that what he likes in working at Nomagic, that we are trying to solve the things which are not done yet or not done yet good enough. Very little companies in the world are doing similar things. So it's difficult to look for very specific inspirations around you in the world. You are looking for the things like to mimic something or to try, like it's. Now I'm thinking about, how we call it in management 3.0, mojito method. So sometimes we take different things from the market and try to add something from us, and based on that create some new ideas, new solutions.
Yeah, but like my question is more about the hypothesis. Is it a hypothesis about the solution, or a hypothesis about what the client wants, or where's the product?
About solutions, about specific solutions, specific steps. What clients want, we know it. We know it quite well. Mm-hmm. So this is on us. There's a lot of exploration, brainstormings. I would say that we are producing hypotheses every single day.
How do you gather data for what the client wants? What kind of workshops?
It's a matter of communication with the client, understanding their needs. So our customer success team is having a call. They are doing research. They are also looking at competitors, because this is the reality. We are not the only that kind of company in the world, but there are not so many. And basically, thanks to the information from the client, what we end up usually with, when we fully understand the use case, we have a human who does that. So the ultimate goal is to do the things with the parameters that the human can do it. So we have this reference. Actually, we do not need a hypothesis in that. We have a human being. We even have recordings when our customer agrees to do that, of the human who doing that for minutes or hours, and we analyze that. Thanks to that, we understand how the human works, what kind of movements they does, and then we think, okay, we know what is the goal, what should be in the end, we know how this process will end, but how to replace that human.
So it's super cool that you are customer driven. Have you actually ever had the problem that you want to do it other way around? So I used to work at a similarly technology heavy company, and sometimes you would have the situation, oh wow, this is actually possible, we have something really cool, and then we have no idea how to turn it into a product. So sort of sometimes we're customer driven, sometimes we would be actually technology driven. Would that ever happen to you?
I'm thinking now out loud. So when I look at our owners, at our founders, I think that they are looking a lot at customer. So it does not mean that we do not have what we are saying, but still I think that the ultimate goal is use case of our clients, and good information for us is, okay, let's say some of the things clear. Speed of the robot station is one of the parameters. We can measure what the human can do. So basically, we are in this position like the goal is so generic, or the goal is related to some kind of KPIs, let's say, that what is the solution is up to us. But of course, if we modify the station of the client, we have to do it in collaboration. So I also think that from our perspective, this trust built between us and the customer is very important, because, again, Justyna stated that already a few times, we are early stage startups. Without trust, our client needs to trust in us. Without that, we can easily land up with a situation like the customer say, take this robot and go away. Tomorrow I don't want to see you at 10. So I think that because of where we are, because of many things that we can still do, we have a big unrealized value, a tremendous, I would say. So we can win a lot if we have a good collaboration with customer. A customer is willing to make our life easier, because, let's be honest, when you go firstly to your client, you're still learning. So you will not come like from the very first day with the highest KPIs possible. So you need this trust from the client that they say, okay, I see that it's working. It's not as fast as humans so far, but what is your plan? What is your plan? What do you want to achieve? How we can work together? So from our perspective, collaboration, doing some joint efforts with the customer and having this understanding that sometimes we will fail. We are in the hypothesis world. We are always in these glasses. So we will never know, even if we try, okay, we can commit that we will do the best that we can, but the complexity of our world always is bringing some unpredictable problems.
I was actually thinking of unpredictable benefits because, we are focusing on some clients, right? But there are plenty other applications with technology, right? And do you put any effort in defining those applications for new clients?
For new clients?
Yeah, so you have this cool technology, right?
Mm-hmm.
And by only focusing at clients you already have, you are might be potentially missing out of the other clients that you haven't considered.
That's a good point. However, I think that because of AI, and we already observed that, to be honest. So we already observed that learning from the first customers are gradually paying off. So I think that because our system is designed in such a way that it expects unexpected. Oh my God, it sounds like a bit corporate now. Well, it's strange what I said. Okay, because our system is designed to face such issues, I think we have some kind of benefits already there. And if we have a lot of things already solved, like how to move effectively with the robotic arm, if we know that, okay, these are kinds of the robots that work well, these are the grippers that work best. So then it's getting, I don't know, for example, to gather data, to teach our system, but it's getting more and more comfortable for us. So this is why, again, I believe that our first clients are very important for us, because when we create very good, stable products with them, independent and helping to do those tedious, boring things, we can expand easily, or relatively easily, because again, copy-paste does not work. Yeah.
I like the approach when there are three types of hypotheses. A hypothesis of the problem, hypothesis of the solution, and hypothesis of the benefit. Do you address them in a different way, or you combine them as a whole?
Hypothesis of the problem, of the solution, and benefit. Well, usually when we create a hypothesis regarding solution, we also incorporate hypothesis about benefit. And the reality shows that we are guessing. We have some data to support that. Sometimes it's better data that will lead to better result, but sometimes this is limited. So I think that we combine those things. Like it's a good point that hypothesis on different levels and coexisting. Because again, what clients likes, what you probably experience, is that when it will be, what will be the impact, give me exact numbers, and what we say, dear client, we are in the hypothesis world. Of course, we are trying to do our best, but let's be honest, sometimes we are quite good, but neither exact to the point. Sometimes it's a bit less, sometimes it's more. It happened even recently that we have very good results, that we expected good results, but were better. But we will never know.